Thank you, Rachel. As Rachel said, I'm Steve Van Laer. I'm the CTO for Anjuna Security, and our next speaker will be coming from Oracle, and that's also in my background as well as Boeing. I've done an awful lot of work in defense contracting, security, and AI through my career, and they all sort of come together in confidential computing. So, as Rachel said, I will be talking today about how confidential computing can make a real difference in the value of the applications that people are deploying in the real world. As Injuna, we are connected with the Confidential Compute Consortium. If you don't know about them and you're interested in confidential computing, I highly recommend you check it out. We also work a lot on the regulation side with CSA and MITRE to help the evolving landscape of how confidential computing is used and managed. So the first place I want to start is confidential computing involves two new capabilities in the CPU. One of them is isolation, and this is pretty easy to describe. Pretty much any application, any agent, any service, anything that's running on a CPU, if it's working with encrypted data, it's got to decrypt the data to make use of that data in memory. And while things are in memory, they're exposed. And we long ago started encrypting hard drives. We long ago started encrypting the network. The last thing we need to do is we need to protect the applications. We need to isolate the applications when they're running in memory. And so confidential computing was created by the hardware vendors IBM, Intel, AMD, NVIDIA, ARM. They've all created capabilities that enable us to isolate and protect our applications from the kernel, from bad actors, from anybody else that we don't want to have access to the things that are there. All of the clouds support confidential computing. Question I get a lot: how do I get my hands on this stuff? Pretty much any cloud instance you want to work with, you can get at Azure or Google or AWS, IBM, Oracle. It's all available in the cloud today for your use. So isolation is the first thing that we need to focus on. The second is trust. So attestation is a process for proving the code you put into an isolated space is in fact the code you intended to put in that space. So once I know I have the right code in the right place, I have a guarantee of trust. And confidential computing in part enables you to reason about a smaller space and make claims about the security. And so one of the types of problems that people want to solve is a data problem. You have data, I have code. Can I have your data? The answer to that question is usually no. You can't. We don't want to share PII information. We don't want to share sales information. We don't want to share models because there's a trust problem. And confidential computing is targeted at solving those trust problems by using attestation and isolation to be able to mix these things together in a safe way, to have an escrow space, if you will, in the enclave to do what we need to do. So here at Injuna, our goal is to ultimately make confidential computing just simply computing. Drop the confidential. It is the default state in the future, we believe. And we want to make sure that this trust and isolation that you want to take advantage of is frictionless. So the first part of our tech stack enables you to build images wherever you want to build them in your system, separated away from everything else. And then the second part of it enables you to run those instances. So we'll support whichever cloud you want to use. We'll support whatever on-premise instance you want to run. So you target the application, you target the environment, and then off you go. We want to make this incredibly simple to use. Because if you do that, if you make confidential computing simple, it has the ability to protect not just a single CPU, but you have real end-to-end protection. You've got protection in memory when your application is running, whether it's an agentic process, whether it's a clean room application, whether it's an application you're trying to prevent attacks against, whether it's a high performance compute solution. All data is born in memory. It's protected there. You load it into a, TLS transport, send that over the wire to another box that's also protected, and you can keep truly end to end your entire application and your entire estate. So we've talked a bit about confidential computing. Let me talk a little about some real world use cases where people are using this today to gain significant advantage in their applications by taking advantage of trust or isolation or both. So, the first I want to talk about is an example of a bank that wants to isolate their cryptographic services to speed up their go to market. So, why would you do this? Well, we all put our keys in an HSM somewhere. It's locked. We've got a hardware module that's protecting the keys. But as soon as you move the keys out of that into some sort of infrastructure, that data is exposed. And that presents a risk to the overall business. So, what a lot of organizations do is they then take their cryptographic functions that are going to work on those keys and do that work, and they isolate them on a separate network. Perhaps that network is sitting on prem somewhere so they can get some isolation guarantees and get some protection guarantees. By using confidential computing, by moving that into the cloud, you can move the cryptographic functions next to the applications that are using those functions. And you can gain significant performance improvements in your application, as well as getting significant advantages of isolation and trust and security for your applications just by picking those cryptographic functions up and isolating them a different way. Instead of putting them on an air gap system, instead of putting them in a isolated on-prem solution, you can move them where your compute is actually used. And so this gives you the ability, this gives the bank the ability to move faster and to be more nimble in their activities, which is why they're investing in this and why they are doing this. The end result, they have minimized greatly the exposure of PII and keys in memory for various operations, be it PCI or just processing whatever privacy information the bank has access to. You have a longer key cache period because you've got significant improvement on the application, as well as the ability to not have to go back to the HSM so often because you've isolated the data and you've isolated the cryptographic functions. You've cut out a tremendous amount of insiders from the circle of trust because somebody who manages the system doesn't necessarily need access to the memory in these systems. So, by eliminating those attack surfaces entirely, you can really increase the integrity of the overall system and what you do. Um, I have a picture of what this looks like, but I think it's even simpler if I go through an example. So let me switch my screen here real fast. And let me do a walkthrough of what this looks like. So the bank may have processing kind of around the globe. I'm going to focus on a UK data center, and they've got data running at a variety of different clouds, whether it's AWS, Google, or Azure. And the way their functioning is set up is when a user dials in, they hit the application in the cloud, which then it bounces against the on prem data center. And the cryptographic functions are living in that data center. So while all these applications are there, the performance penalty is the fact that you hit a processing system or you hit a fraud prevention system or you hit a payment system, and you have a lot of back and forth to the on prem data center, which turns into a real world cost to the end user. So by picking up those cryptographic functions, moving them into the cloud, protecting those with confidential computing, you're able to fit in a lot more processing in the same amount of time and also reduce the amount of time that the end user is waiting for a process because you don't have to go back to the on-prem systems for every single request and go get those cryptographic functions performed. So this is what the enablement of confidential computing is doing for the bank. It is significantly improving the performance of their applications. It's enabling them to put more applications in stream with individual requests while providing all the isolation guarantees of what they're after. So let me talk about a different use case now. Second use case, different bank we're working with. And they have a long history of data with their customers. And in particular, what they wanted to be able to do is they wanted to use purchasing information to provide targeted offers to their customers. So for their high worth customers, they wanted to understand their purchasing trends, understand what they're doing, and then make special offers for those customers. The challenge is they needed to combine data from a variety of different sources to be able to pull off this activity. The joins are pretty straightforward. Pretty much any intern computer scientist can join from table A to table B and make the offers. The challenge is a risk problem. Do we really want all of this data exposed in one place? So, what they needed to do is they needed to have customer data from the bank, including their history with their balance and the various account information that the bank has. And they needed to pull some retail partner data together and merge that with some AI models to drive some new activities and new results. And this is hard to establish the trust and confidential computing, the ability to run these models in a space with the data where the model owner can't get access to the data owner can't get access to the model, but we've isolated off the actual compute, enables driving business outcomes that they couldn't achieve before without confidential computing. So this clearly lands in the space of new use cases, new things you can do with confidential computing that you couldn't safely do without confidential computing. So this particular bank got significant increases on their ad spend. They were processing millions of transactions a day. They were doing a tremendous amount of inference, significantly reduced the exposure of PII risk by moving all of this into confidential computing. Even the people running the system don't have access to the data, don't have access to the models. So this gave them the ability to really test out and work with their partners to establish a better business outcome because of the abilities that confidential computing gave them. Last one I want to talk about is AI and agentic AI in particular. Um, LLMs have essentially cracked the NLP problem. So, natural language processing is now within scope of what we can solve with computer science. And everybody's excited about what you can do with LLMs. But thinking about what you should do is a much harder problem. LLMs are non deterministic in terms of what you get as a user. So if I put a prompt in and I ask an LLM to go give me a result, I won't necessarily get the same result each time. Any of us that are demoing with LLMs know this means every time I do a demo on an LLM, I may get a different result and I may have to stay on my toes in terms of what I'm doing. Uh, what we're doing with customers is providing a trusted execution environment space for a supervisor model. So let the agent be the agent, but bring the supervisor into its own space. And by protecting that supervisor, we prevent it from being tampered with. We prevent the prompts from being modified. We enable it to focus on what should you do as opposed to what can you do. And it's going to supervise the behavior of the agent itself. So you have a place for both static and dynamic rules to be executed, and it can see into what the agent is doing and make decisions about whether this is appropriate or not. So with these adaptive supervisors, you can match the flexibility of the agent with security policies that follow in line and are focused on doing what the agent should do. So what does this look like? It looks like a pretty straightforward injection into the middle of an agentic model. So the separations of duties live by the fact that the agent itself, you let your developers develop the agents. So the folks that we're working with on this, they're going to put an investigation together that says, investigate the root cause of this failure. I'm looking at the logs. I then want to go look at a knowledge base, make some decisions, take some actions. Pretty straightforward use case today in the agentic world. My time at Automation Anywhere, this would be an RPA use case that would be pretty common for what you can do. Well, the separation of duties, what I want is a second agent that has a policy that's determined or a prompt that's determined by the CISO policy. It's going to have access to the context of the agent. It's going to have access to the prompts of the agent and what the agent's attempting to do. And it will ask a different question. As a CISO, I want you to look over this agent and make decisions about what's appropriate or not. And that agent manager is going to provide access to tools. The agent manager is going to provide access to data to the agent. So you don't have to give credentials to the agent. You can give the credentials to the agent manager, which is running at confidential computing, and it's going to make a zero trust decision based on each request. Just because I gave access to 10 minutes of this log file a second ago doesn't necessarily mean I'm going to give another set of access to that log file if in fact I think the agent doesn't need it anymore. And so the agent and the agent manager will have their own dialogue back and forth, with the agent manager kind of looking over this intern of an agent and protecting what it is doing. So this model is one where we use confidential computing to provide a trusted space for managing the agents and supervising what they do. So overall, we believe very much that confidential computing can be both low impact or low effort and high impact. Make it very easy to get applications into confidential computing, do it significantly faster than rolling up your sleeves and trying to get to core first principles, as well as the impact it can have on the business in terms of reducing how many MITRE attacks do you have to worry about, increasing the amount of revenue you generate, increasing the performance of the application, and getting there quicker. So that's what we do, and that's what we focus on, and that's what we think confidential computing has the potential to deliver to the industry. So thank you very much. I'll leave this up here. There's plenty of links to figure out free trials, data sheets, white papers, walkthroughs, anything else that you may need.
Amazing. Thank you so much. We will be sending around an email after with some links so that people can get there very easily. But that was great, and I really love the we think confidential computing should just be computing. So I think that's
Absolutely.
great. All right. Thank you so much. We'll be talking soon.
Okay.
All right.
I'll respond to questions if there were any in chat.
Thank you so much.